two, one, two, one, two, one, two, one, two, one, two, one, two, three, funk. One, two, three, funk.
And I just realized my mic was off. Well, that's fun. So, let's see. My mic was muted. Silly moi. Okay. Let's do. Could we do a recursive function? We could. We could totally do it as a recursive function inside a recursive function. But wait, aren't we essentially doing the exact same thing? Aren't we doing this here inside? Is that what we're trying to do? Not quite, no. Not quite. We could though. Or could we? Not sure. Not sure that we could. Because really we need to start, we need to switch our start point. It's really the only way to make sure we cover every possible rectangle. If I were to take the largest rectangle, then evaluate it, then reduce that, reduce that, reduce that. No, we're still missing out a bunch of, it's the same thing. Same thing. So we are going to do, I think we're going to do a loop. So for, now we need to get the value into the array. So we're going to need nested loops, my favorite. The I, or a line, let's call it line index. Or maybe I could just go, yeah, that could be fun. That y, which is our lines, equals 0, and then when y is smaller than rectangle dot length. Keep going, otherwise you stop. And y plus plus. Nope. Got this wrong. I already have my starting point. I don't need to switch. Oh yeah, I do need to switch lines for each lines. Starting point stays the same, but we want to move the end point. Oh, wait. Wait a minute, I'm mixing up two concepts here. Could I do it that way? Start point, end point, score. What does that give us? If we're simply moving this point, end point 4, so we're essentially here, this function will give us one sub-rectangle in our array. Right. once we're done, we can simply change the, okay, I think I'm starting to see something here that could, okay, so all we need to do is change the end point after we've evaluated. Or all right, let's start by one subrectangle and we'll see. So for let y equals 0. Nope, that's not true. Let y equals start point dot y. Okay. And then if y is smaller or equal to endpoint dot y, so that will iterate through all our possible lines. And then we need to iterate through all our possible columns. Point dot x, x plus plus. Okay. And we've got our y, we've got our x, and we're able to get our value. So all we need to do is take increment this square plus equals doing this, I'm not using the recursion at all. I should be incrementing of this. Ay, ay, ay. That's just dumb. Let's try this instead. Rectangle. Start point dot y, start point dot x. If I do this like that, and we go score plus equals. All right, so we've got our starting point here. Yay! And what if? I just thought of something. I think I could use this new MDN array flatten. What does that do? It takes a 2D array and it flattens it up. It would be much easier to get the values, I think, if we could do that. Can I, though? Let's see what happens if I try to. No. I'd need to extract that into a separate subarray and then flatten it. It comes down to the same thing. Well. How about we do some rect. How's that? Let's break them down. We got our start point, we got our end point. Simplest thing, simplest thing. Let x, or y should I say, y equal rectangle equals start point dot y. Yeah. And as long as we're smaller than our endpoint dot y, it should be inclusive. Start point dot y, increment ry. Okay, so that will take us through every line. Then for each line, what we want to do, and then I guess I really shouldn't have this here for now anyways. Should simply have a let sum equals 0. And for each line, for let x equals start point dot x, right? As long as x is smaller or equal to the end point dot x, we keep going, and x plus plus. And then what do we do with that? We just take whatever the value of rectangle. Y, X, I always thought that was counterintuitive, using 2D arrays. And that would be it, right? That would be it. So let's test this with this input here, which should give us a grand total of 11. Sum rect. Start point is new point with an x of 0 and a y of 0 and an endpoint of index 1 and 1. Let's give that a try. Found undefined. Well, that's not good. It's probably because I'm not returning it. Gah. That's why it's often a good idea to type your function's return type. That's what we want. There you go. $11. Okay, so that seems to work. That seemed to work. What if we were to play around with this and say, oh, I want to see what happens if the rectangle starts at index, let's say line 2, or line 1, index 1, so here, and ends here. So basically this will be our rectangle, and we should get 15. Which incidentally will pass our test too. No, maybe not. Found 0. Unacceptable. Wait a minute. Y of 1. Index 0. And the endpoint is 1, 1. Why would you not work? If y is 1, right, we keep going. Oh, no, that's our problem right here, I think. Or is it? No, that should be. Y, X. Technically, we should only get 2 inputs. Two outputs, I mean. -9 and 9. Oh, I think I screwed this up. Got this the other way around. I've got my X and my Y's mixed up. Oh, yes, I do. I do have them mixed up. It's XY, but Y is that's always kind of confusing to the arrays, man. Because, right, usually, like a graphical representation of it, 2 axes, Y and X. Normally, the up-down one is the Y, and Is that right? Yeah, I think so. The horizontal one is X. But when looking at a 2D array, it's kind of the Y comes first, right? Usually you represent X and Y, but in a 2D array, it's YX. You're looking at the vertical first, and then you're going with the horizontal, but normally when we're talking coordinates, we usually give the X first and the Y after. Anyways, I'm often mixed up with that. Okay, so this should work. I should get the number 15 as an output. Yeah, okay. But that's only part of the thing. So we've got a function here that will evaluate a rectangle given a starting point and an end point. But we need to go and take our entire rectangle and find the value of each possible sub-rectangle in there. How do we do that? And that's where maybe some kind of recursive function could work. And now that I'm thinking about it, this function could probably be made recursive. All we really need to do is change the start point. No. If we change this, we need to change the endpoint and the start point to make sure we're getting everything. Oh no, we don't. We don't. Or do we? Hold on. Yeah, we do. We do. We need to change both the start point and the end point. Could we do that recursively? I first need to go through I need to try every possible endpoint for each start point. So I need some sort of for loop here. Where I'll go through the entire let's see, I'm just thinking here because yeah, I bet there is a way to have like just the one recursive way of doing this, or because I'm ending up with like a lot of loops inside loops, and I have a feeling there's a more efficient way to do this, but let's just do it that way. At least try to solve the puzzle, and maybe afterwards some kind of optimization will come to light. So I basically need to go through every start point. Let's just call it line, or no, we could probably use the same kind of just going to start at 0. We know we want to do the entire thing. So, and then if y is smaller than rectangle dot length, we keep going. Increment y. So for each line, and then also another one here, let x equals 0. X is smaller than rectangle y dot length. Oh, silly, I already have those. Yeah, I don't need to use that. I can just go height, and here I can use width. Anywhere else where I'm using this stuff? Nope. Okay. And then x plus plus. Okay. So this here will get us through every start point in our global and for each start point, I want to wow. This is harder than I thought it would be. For each start point, I need to get the sum of every possible rectangle. I do that by changing the endpoint. Ay, ay, ay. Oh, I can't help but think that there's a way to do this in one big recursive function. I've got everything I need here. I just need to find a way to modify this once I've gone through one. So basically, I need to, let's work with this. I think I can figure it out. This here will calculate, and if we're starting with our global, like our biggest rectangle, well, we'll get the sum of every single point in that rectangle. Now, once we're done with that, right? Once we are done with our for loop, well, we need to, if I want to get everything, we need to simply change the end point. So by doing this, see if I call, okay, but I gotta store this. Let's see. Let's get rid of this. Going back to the idea that we are caching the best sum. Forget you for now. So this will take us through the entire best sum, we'll call that. We'll keep our local one here. Okay. So once we're done looping through our entire rectangle, we need to move on to our next rectangle. Our next rectangle will have the same starting point. We'll just change the endpoint. How are we going to change the endpoint? We're going to... Oh, do we need to change the endpoint? I could just go through the start point. If I'm doing the entire thing like this, then I end up with a little account here. Then I change it. I go like that. But then I don't have the line rectangles. Wow. Either way, I gotta go through like this and like that. Ay, 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 ay. All right, so we're gonna start by decrementing So let's start with this. If endpoint dot y is bigger than start point dot y. Go first of all, once we're done with that, let's check if our sum is bigger than the best sum that we've got so far. If it is, then what? Then let's just make best sum equal to sum. Yeah, let's do that. Then, if endpoint y is bigger than start point y, we get to call our sumRect again. Start point stays the start point, but we're going to change our endpoint to be new point. That will take our endpoint endpoint dot x and endpoint dot y minus minus. And just bring over the best sum. Okay. So I would do the same process, but this time with one less line. And then with one less line, 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 until it's done every line. If endpoint is bigger. Okay. And then when it's done that, if we're done with all, well, actually, I don't have to, because once we're calling this and calling this and calling this and calling this, then essentially the same thing, right? If endpoint.x is bigger than start, then we're doing x minus minus, endpoint.y stays the same. And that would take care of, I think, all of our and then we would get to a point where the end point dot x would be equal to this equal, because that's going to be our stopping. Our stopping thing is when it gets to be smaller than 0. So endpoint is smaller than 0, and endpoint dot y is smaller than 0. Then that's the sign that you've gone through the entire thing. Not even, because then I need to do this all over again by starting the end, by changing the start point. That's not going to work. Oh, it will work. It will work. If I do this here, then I call it, and I change the start point. I change the start point to new start point, new point. Our x is going to be start point We're going to make our start point be x plus plus start point dot y. And then just endpoint. What's going to be our endpoint at that point? It's not going to, oh my boy, this is complicated. Nope. I don't think this is gonna work like that. Let's go back to just our sum rect. We know that works. Back to our idea of going through every start point possible. So for each start point, okay, maybe what I need to do is to turn this into a bit more of a readable thing. So how about we'll call this start points. We'll make ourselves an array of points. It'll be easier. We can just iterate through that. So start points is going to be an array. Actually, I can probably for, let's see if I do for, I basically end up doing the same thing, doing the work twice. Let y equals 0, y is smaller than height, and then y plus plus. Basically end up iterating twice just for the convenience of no. So let's do it that way. For let x equals 0, x is smaller than width, x plus plus. Did I do something wrong? Did. There we go. Okay. So now we're essentially dealing with width. Starting points. That's going to be our starting points. For each starting point, I need to call sum rect. New point. X, Y. Endpoint point. Height -1. Width -1. So doing that is only part of the we also need once we're done with this is getting so once we've got our start point here, which is basically this here, let's do that. Const start point equals new point. That's basically this here. We need to go through a list of different endpoints. And that's where it gets just crazy. Because I need to do the exact same loop kind of thing. Let's do it. I don't see any other way right now. So for each start point, let endpoint y equal h -1. Then you keep going until the endpoint keep going until the endpoint y is or as long as it is bigger or equal to start point dot y. Y is u endpoint. Or maybe it would be easier to start the other way around. Might as well. Endpoint dot y is equal to start point. Yeah, let's do it that way. To start point dot y at first. And then as long as endpoint dot y is smaller than h, we're good. Point y plus plus. Okay. Then what do you do? Well, you call sumRect with drive me nuts. Hey, what's up, mate? Yeah, I think last time you were on, we were on exorcism.io. And this one is code and game. These are more puzzles. The other ones are more on exorcism.io. It's more like they're exercises meant to teach you about the language. And you've got mentors giving you feedback. This one is really like puzzles that make you use like algorithms and stuff like that. And they can be quite challenging. For me anyways. Like this one. I thought it was going to be relatively easy, but I'm racking my brain trying to find a performant way to do this, because I'm going to end up with like at least three, at least no, it's looking like 4 or 5 nested loops here. That's just insane. But yeah. So just to give you an idea what I'm trying to do here, we're getting an input of a 2D array. So the first line of the input is the width and the height of the array, basically. So this is what you're seeing here. That's what we're being fed. I'm collecting this right here with height. Then you're getting for every h, right? For every height line, you're getting a line, space delimited, and yeah, so in this instance, it's a 2x2 array, and we're getting 5 minus 9, 6, 9, and what we're trying to do is determine in any size array, with different inputs, of course, which sub-rectangle gives us the biggest sum. So here, for instance, this would be the sub-rectangle that gives us the biggest sum. We're getting 15 if we're taking just that into account. But if we were to take, for instance, these two would get 0, these twos would get 11, these twos would get minus 4, and we would get, for the total, 11 as well. So this is the answer we're looking for. And of course, we're going to get to do that with like crazy big rectangles. Now I'm trying to figure out a way to do this, come up with a good algorithm to do that. And so far, I'm just coming up with like a bunch of loops inside of loops, inside of loops, inside of loops. And I'm pretty sure there's a better way to do this. So you're saying exorcism is legit really good. I'll admit that the problems there are a bit harder than most websites for beginners. Oh, really? Because so far, you've got to take a crack at code and game, man. Because so far I've found code and game to be much harder than the stuff I've been running into on exorcism. What language are you doing? Are you using on exorcism.io? Oh, right. It is test driven, but I actually find that easier personally, anyways, because you get to take a crack at the, chip away at the problem incrementally, and you get nice little tests to make sure that you've got a correct solution. Code and game, well, normally people, some anyways, would just use the online IDE, which is right here. You don't get really well, you've got test cases that you need to pass, of course, but they're not they're not really incremental in the sense that they don't break down the problem into smaller problems in terms of difficulty, I guess. Well, sometimes they do, but anyways, it's not easy to debug though. Kind of got to do a lot of console log stuff. All right, so I've got to call this here, this function that I have here, to get the sum of the rectangle. Yeah, it is. It is next level. And this is, you know what? I don't know. The one I'm doing right now, I don't know if it's categorized as easy, medium, hard, or super crazy hard. I have no idea. I just clicked the link from the puzzle of the week, and I think the puzzle of the week sometimes it could be any kind of difficulty level. But I've done most of the easy ones are relatively easy, but I think some of them are like kind of miscategorized because I've come up against a relatively hard puzzle the other day that was categorized as easy. Which one was it? I think I did a live Twitch of it too. Oh yeah, robbery optimization. If you get a chance to try it out, it's not the hardest one, but it definitely requires some thought. Okay, let's focus a little bit here. I'm trying to get, what am I doing here? For each start point, that's what I'm doing here, right? Yeah, this will give me each start point. I need to get all sub rectangles from that start point. So first, I'm going to do that by just keeping the x coordinate the same and changing the y coordinate of the endpoint. So let's do that. Sum rect, our start point. Already have that. Whoops. What did I do? I don't know what I did, but start point, yes. And our endpoint is going to be are we keeping start point dot, yes we are. Start point dot x is going to be our endpoint. The only thing we're changing is is the y. But if we do that, now we're essentially getting it for each, just at the line, right? Or if I am to, let's say this is my start point here, and I'm saying, okay, here's our endpoint, and I want the endpoint to be here. That's what I'm doing. Then I want the endpoint to be here. So I'm incrementally calculating this, but then I need to go down. So start point stays here, and the endpoint needs to be here. So then we need to increment the y. And then, see how this gets into like crazy nested loop territory? This is insane. There's got to be another way to do this. I'm not figuring it out. That's weird. So add one, then do the entire thing. Calculating this, calculating this, calculating this, calculating this. And you go here, you add 1, and you calculate this, then you add 1, you calculate this. Brute force solutions tend to be messy to write. Yeah. I would agree with that. I would agree with that. So, what are we saying? Are we thinking that we should just use some kind of other algorithm to get the biggest rectangle? We could. We definitely could. I just wrote a hill climbing algorithm that could be used here. And I'm starting to think that it might be easier. But I'm sure that's not what they're expecting for this. Well, I'm sure. I'm not sure, I guess. But for some reason, I keep thinking that there must be like some kind of nice, neat little recursive function we could write that just takes... Because it looks very like recursive-y to me, right? We're calculating a small rectangle and then a bigger rectangle and a bigger rectangle, and that's what we're doing. We're doing the same thing on just on a different scale, but the thing is we're doing it in different planes or I don't know how to explain it. There's just something I'm not getting here. But I'm seriously tempted to just implement like some kind of random thing that'll just go and try everything randomly and just eventually find out the best solution. That would be hilarious if that's the way I go. Yeah, maybe I should. Because I can't wrap my head around finding a better way than just like crazy nested loops. Yeah, that's what I had in mind, right? Like the hill climbing algorithm is a greedy algorithm in the end. You can add a little bit of randomness and stuff, but I think we could do it that way. And I'm seriously starting to think that it would be less annoying, at least, than this crazy nested loop thing that I'm doing right now. Bam! All gone. Starting from scratch. Just making the rectangle you can and subtracting the net negative sides. Whoa. Not even sure I understand what that means. The net negative sides. But I don't know. I'm not a computer scientist for a reason. Yeah, me too. And Code and Game reminds me of that every time I try something on there. That's basically the my go-to for every hard puzzle is like, you know what? I can't figure out the correct, algorithm to implement to get the absolute optimal answer. Let's just use the computer's power and let it try randomly every single possible, parameters, and hope that it'll eventually find the right one. And it often works pretty well. So why don't we try that? That'd be fun. Because, I mean, we're just looking at 2 parameters. Well, I guess 4 parameters here, right? Oh, I shouldn't have deleted all of it. I have one useful function here. My sumRect function. And okay, so this is good. This is We're basically feeding it the start point and end point of a rectangle, and it'll just give you the sum of everything that's in there. So we can keep that and use it in our, what should we do? What should we do? A hill climbing algorithm would be good, I think. Oh yeah, it does. Let me show you. But it's kind of, so that's the first one, see? It's saying this is the input you're getting, and this is the output we're expecting here. And then after that, this one, as you can see, it can get pretty intense. So let's do this. Let's do this. So the first thing we need to do in a hill climbing algorithm is to start with a random point, right? So let's make a function generate random, well, not points as much as because it's a rectangle, so generate random rect. Okay, let's do that. This will return a rect, which I haven't defined, but I will now. A rect is simply, let's call it a rectangle. Don't need to abbreviate everything all the time. Rectangle is simply a, let's see, public start point, which is a point, and public endpoint, which is a point. That's how we define our rectangle. Definitely not your average interview problem you can whiteboard, that's for sure. I would get so wrecked if I got, yeah, me too. The worst is it might be. There's a bunch of puzzles on Code and Game that I've been told or read articles that did come up in some interviews. Apparently. So I don't know if that's one of them, but yeah, if it was, I would be screwed. Okay, so we're expecting a rectangle from this function. How are we gonna generate that? Well, it's not too complicated. We just start by generating randomly one point, a start point. So our, oh, but we always want our start point I'd love to try coding games sometime. My goal at the moment is to finish the Python track. So far I'm on exercise 13 out of like 120. You're talking about exorcism, right? On exorcism.io. So that's pretty good. Exercise 13 of the core track, like the core exercises, or are you including also the side ones? Generate random rect. Okay, so we're starting, we'll generate our start point, so that's not too hard. We're just gonna have to no idea. I just click on the Python track and look at the first 13 problems. Okay. Might not work the same way as a TypeScript track, I don't know. I like Python. It's a nice little language. Okay. I'm more familiar with JavaScript, TypeScript, but I've written a little bit of Python. They're kind of similar in the sense that they're both, you know, higher level scripting languages. That's true. You don't have the brackets, right? That's kind of nice. Once you get used to it, and it's pretty easy to get used to. The thing that makes me use JavaScript a bit more than Python is TypeScript, really. I think that if Python would get a popular version of TypeScript, you know, for Python, I think that it would get really popular. That's what I think, but okay. What are we doing here? We're generating a start point. So const start point equals new point. What are we going to shove in there? We're going to shove a math.random times our, what is this, h, so that's times our w, and we need this to be a math.round, value to be rounded to the nearest number. Yep. I definitely love languages designed with developer-friendly syntax in mind too. Yep, TypeScript's a good example of that too. I think so. I really like the typing syntax in TypeScript. I like more than in, for instance, C#. And it's not bad in C# either. I think it's more just whatever you're used to, I guess. Oh, that's definitely true. It is hard to write Java and even C# without an IDE. Like, I don't know if anyone does that in just a text editor. Python, JavaScript, you can do it. You can do it. But even then, why would you? Okay, so we've got our x here. Am I doing this? I'm generating a random, which is between 0 and 1. I'm multiplying that by the width, and I'm rounding that. So, yep. That should work. And then same thing for our y. I'm not doing this in the right spot though, am I? New point. Just need to do this. But this time with the h. Okay. So that takes care of generating our starting point. Now for our end point, this will be a bit more complicated because I want the endpoint to be, let's see, either equal or bigger than whatever the start point was. How am I going to do that? Oh yeah, let's think about this for a sec. If I'm doing math.round, I'm ending up with something between 0 and 1, if I recall this properly. Now, if I multiply, how do I bound this? I can't remember how to do this. Do you remember how to do that? Right? Like basically a bounded random. Just give me a random point between this and that. Python has probably has that right in the standard lib. That's the one thing about JavaScript that I wish you know, they would come out with a better standard lib. Someone has fixed that or solved that for sure. So let's just build on this. So JavaScript, bounded random. I don't know if that's range, random range. Yeah, random range. Oh, do they even give you the math.round times upper bound minus lower bound plus lower bound? Yeah, that would work, right? Wouldn't it? Just upper bound, lower bound, plus lower bound. No, I think you're right. But look at that. I think we're about to have confirmation right here. There you go. That's basically what you do, what you just said. Yeah, upper bound, lower bound. There we go. It's kind of silly that, you know, the docs for math.random tells us how to do something that really just should be in the standard lib. But whatever. Okie dokie. So, should I just shift that in there? Times max, R max, and it is, yeah, I do think that, like, I get the idea that they don't want the standard lib in JavaScript to be like super bloated, you know, given that it's all browsers, but I mean, computers are getting pretty powerful, and mobile devices as well. So I don't know. I think it's time that they include some of the stuff we're used to having in other languages. But that's just me. Okay, so our max here is going to be our, we're dealing with what? X is the W. So minus our min will be start point dot x. There we go. Plus start point dot x. Now, is that inclusive? Yes, it is. I would think so, the way this is written. Yeah. And basically do the same thing here for our, so let's put that on. It's getting to be a pretty long line. H, Y, Y. So I think that would work. To be honest, I think you have the right idea, just brute forcing this, since the test cases could be super tiny for all we know. Some of them are. If I look, you can have a you can have an idea of a, where was I? Here. So you've got this is the biggest one, which, you know, for a computer is not that big of a deal. So I think I can get some pretty good result. I actually think using hill climbing, I can get the global optimum every time without spending too much time, too much compute time. We're about to find out because that's what I'm doing. Got fed up of the nested loops. Oh yeah, no, it's not that bad. But here's the catch though, on code and game, so that's something you got to watch out for. So you've got your test cases, and before you can submit, you need to pass all test cases. But once you do that, it'll run your solution through hidden test cases. And I have had yeah, it has happened to me that I would pass all test cases here, submit, and then those hidden test cases, one of them wouldn't pass. And that's a real bummer, because I don't remember if they actually give you the problem, like what failed. I think they do, but it's kind of hard sometimes to figure out what you did wrong. Okay, so now we just need to return a new rectangle with a start point and an end point. Okay, so we're set for that. We've got our, so let's start by doing that. Const starting rectangle equals generate random rectangle. Thank you. Okay, now how does it work? We need two. Once we've got our starting rectangle, we need to score it, right? So const best sum equals, now we take, oh, and this is what I'm going to do instead here. I'm going to use my rectangle of type rectangle. Oh, I need to change that a little bit. Rectangle dot, yeah, rectangle dot oh, nope. This is actually referring, oh, I've got a rectangle thing here. Oh, yes. Okay, so let's call this global rectangle. Global rectangle. Global rectangle. Okay. Hey, can you do me a favor? Could you try, I don't know, could you try maybe like choosing a song with using that song request command thing? Just for kicks, see if that works for you. The way it works is just type in exclamation mark, song request, or actually I think you can just do SR space, then just type in the title of whatever song you want to hear. Best sum equals well, quite simply, we just sum rect, then starting rectangle. Okay, so now we should have, let's log that, see what happens first. Yeah, look at that. Looks like it works. Is that the song you had requested? Is that what you were thinking about? Cool. like it too. It's good programming music. All right, let's see what's the cannot read property 2 of undefined. So we're off to a great start. Starting rectangle, our starting rectangle. Oh, okay. Well, let's see if I can just do... Okay, so this must be from my backup playlist, what's playing right now. Oh yeah, backup playlist. You're playing, queue is empty. If I do next, what happens? No, that's still from my backup playlist, isn't it? Let me check something here. Let's go to streamelements.com, dashboard. Media request. Added to the queue. Porter, Robinson, and Medion Shelter. It's weird. I don't see it. Huh. But it does say that it was added to the queue. Maybe it'll only play at the end of our of my backup playlist. Maybe what if I skip and skip and skip? Puncher. No. I really don't know. Whatever. I'll have to look into that. So what are you saying? I need some workspaces for your Windows. What is that? I am using a multi-monitor setup, which you're not seeing, no. I've got all my Twitch stuff on the side, the chat. Okay, so we're having a problem here. Cannot read property 2 of undefined. Online, answer.js, no online 27. What is that? Answer.js. Oh, that's interesting. I'm gonna have to debug that, but you know what? I'm out of time anyways. Oh, there's something I wanted to try. If you guys don't mind. I wanted to try rating. Rating. How do I do that? There must be a way to do this here. I need to type in a command or something. Extra desk workspaces, extra desktops, essentially. It's mostly useful for people on laptops, one monitor. Okay, is that a feature in Windows? I've never really looked into that. All right. Let's see. built into Windows 10. Oh, I'll look into that. That's what I'm running. So we're gonna raid Fun Functions stream. He's on right now. So thanks for watching, guys. I'll be on tomorrow again at 9. Take care. Oh, I guess we have to wait a little bit before it raids or something. 2 viewers are ready to raid function now. Oh, you're gonna like this. The guy's called MPJ, and he's from Sweden, and he's got this nice little YouTube channel, and he does some Twitch streaming too. It's mostly JS stuff, but he talks about development in general and different things really that revolves around development. He's quite good. He's entertaining, but also he teaches stuff that are, interesting sometimes. That is interesting. Rating equals hosting another stream. No, not really. We're just kind of, rating is when basically sending everyone to the other streamer. You're going to end up in his channel.